Hello everybody. Today we are going to discuss data flow diagrams, and we are going to develop an understanding through different examples, and we will see that in the context of modern software engineering, how do we see the data flow diagrams. This lecture is the continuation of our previous effort of understanding the concept of modeling and the concept of understanding the requirements at the requirement elicitation level. As a part of the requirement engineering in a larger scope, data flow diagrams are very popular when it comes to the describing the functionality of a function in order to develop a visualization of the requirement of a client and the visualization of a system. Data flow diagrams play an important role. When we talk about feature driven development, we talk about the data flow diagrams, and data flow diagrams actually let you know that how data actually flows as in and out of a process. If you would like to understand how the data is given to a function and what actually is the expected outcome out of that process, then data flow diagrams can play a very vital role in order to give you a proper understanding. DFDs are just like figures, they are pictorial, and we are going to see that in a minute. When we talk about data flow diagrams, they are very concise. And when you look at the diagram, no two persons can take two different meanings out of the context which is given to you. At the same time, data flow diagrams are unambiguous. When we talk about the data flow diagrams, they not only tell you that what is the expected outcome out of a function, but we can understand the system as we move along and decompose and explode that process into smaller sub-processes, subsystems. So it not only gives you a physical idea about the context of the system, but it also gives you a very well-defined idea about the logical connections between different processes. The data flow diagrams, they facilitate you in a top-down development. Whenever you look at the system, data flow diagram give you a facilitation where you can draw an outline outside the system, where you can actually define the preferences and scope of a system. For example, when we talk about an ice cream machine and a machine which is preparing the ice cream, there are different functionalities involved in that. So the dispenser, the mixer, the electricity system, all these things are a part of that ice cream machine. But at the same time, we need to understand that where they are integrated to perform the ice cream making function, at the same time, they are independent, and also with their independence, they can perform individually in their own context. So data flow diagram is something which explain this in a very well formatted way. In order to understand one of the airline reservation system, we need to see that this is one of the example of the data flow diagram. In this system, first of all, we need to see what are different things. These are the arrows. These rectangles are the external entities. These bubbles are the processes. These two parallel lines indicate the record storing or the data stores. So if we look at this data flow diagram, it tells us that a traveler gives time, date, and destination to a make reservation function that then stores information into a data store of bookings. Then the make reservation sends that data to prepare ticket and billing system, because these are two of the uh, outcomes which are expected of the make reservation function. And then that bill and ticket, both of the things are forwarded to the traveler, and from the traveler it is expected that he makes the payment to the billing system. So if you look at this data flow diagram, you see that it is giving you a very clear outcome oriented view of the system. It not only tells you about the physical view, but it also tells you how different functions are logically connected with each other. Moving forward, we see that now we see this that the entire application becomes one single process when we talks about the data flow diagram. And when we look at a system as a one single process, this is when we are talking about the context level ERD. And in this level, we identify the external interfaces. And at the same time, this is the starting point. And we also call it a context level diagram, we call it a fundamental system model, or we call it a level 0 DFD. There are different names to it. Now, if you look at this context level DFD, it tells that there would be two users, there are two rectangles, two data sources. One is the external data source. The data source on the right hand side is the internal data source. And then there are two users, user one and user two. One is giving the input and the other is consuming that output. And a software system is shown as a single software process. In this context level DFD, we actually understand and we identify that what are the external users which are going to interact with our system. Now, the process of explosion or exploding that bubble process, we actually decompose that process into sub processes. It is entirely possible that when we decompose a process into sub processes, it may give you additional data sources, it may give you additional data stores, it may give you external or more internal interfaces. And when we define the database and we exclude the process, we use the decimal number system. For example, if you are decomposing a process 1, you decompose that process into 1.1, 1.2, 1.3. This also give you the a priorited sequential execution of the processes. It tells you that how different processes are connected with each other. At each of the level, we try to develop an understanding that how each of the function is connected to each other. We label the processes, we label the data stores and data flows, and we try to give an understanding that how data is flowing inside a process, and inside a process how that big process is divided or exploded into the sub processes and giving outputs to the different processes, and what is the end outcome of the software. Now we need to understand the DFDs don't have any idea to show you the control flow. Like if you want to see that if there is a conditional logic applied somewhere, they won't show you. It won't show you the initialization of different processes. It won't show you that from where the errors are coming, but it will let you know that how the business processes are actually working inside the system. When we talk about business processes, for example, let's imagine and see an example from the scenario of a university. When we talk about a university, a student when first visits university visits it as a candidate to the admission to the university. Once he applies for the university, qualifies for the admission, he becomes a registered student. Once he pays the fee, then he gets enrolled into a course. He become an enrolled student. When he clears all the prerequisite to the degree that is to be awarded to the student, and he completes the degree, he or she becomes an alumni of that. So it is the same student data which, after passing through different processes, is being transformed into something new. We also need to understand when it comes to the process of refinement and how, and by the way, this process of decomposing processes into sub processes is known as refinement. We need to understand the concept of cohesion. Cohesion and coupling are two opposite concepts which are often taught to the students in the object oriented programming and when they learn about functions. When we talk about cohesion, we talk about the property of the independence that a function has when it performs something. And when we talk about the coupling, we talk about the dependency of that function on other functions. We see that in this regard, when it comes to the data flow diagrams, we see that the only data that we required at this level is the input that is coming to the process and the output that is required from that process. That is the only information which you require at that moment in order to perform, in order to make a diagram, a data flow diagram. Now, if you look at this scenario which is present in front of us, where we are trying to emphasize on the fact that how consistency matters, you see here that an external entity A is actually sending information to a function f1 and giving some output to the external entity B. This big bubble of F1 is decomposed into four sub processes: 1.1, 1.2, 1.3, and 1.4. These sub processes let you know that function F1 is further divided into the sub processes. And in this regard, the F1 is not connected to F4 directly. However, F1 is connected to F2 and F3. It also tells you about the flow of the data inside your function. When we talk about the physical DFD, it tells it shows you the implementation details. It may tell you about names and location and places and people. It also tells you about how and where the card data is stored. It tells you that how the tasks are performed. For example, two persons handling, let's suppose, undergraduate thing, and uh, PG students are dealt separately. The physical DFDs are also one of the most useful products when it comes to describing the existing system in order to validate the functionality. The physical DFD is needed to be converted into a logical DFD at a later stage. Once the physical DFD is validated, then it could be transformed into the logical DFD. If you look at this diagram and you look at the boundary, you see that these circles are different processes or sub processes, but at the same time, it is telling you about the software process and its scope inside a bigger system. So, in this way, inside a data flow diagram, you can also talk about the boundaries and scopes. Now, let's have another look on another example, and that is of the payroll system. Inside a payroll system, we see that the process is initiated by an employee when it passes its employee time card into a validation system that, once validated through employee ID, gets the employee data and from the employee storage and other data and send that validation to a calculate payment function. The calculate payment function includes the taxation information that comes from the tax table, and that sends payment to the payment module that sends to the account, and the checks are printed, and the issued checks are stored in another separate repository, that is issued checks. With this, we clearly understand that how inside a system different data stores are interacting with different processes and what information is to be stored along with function. Now, when it comes to the data flow diagram, another example is the old cart market, where the process of buying and selling of old cars takes place. There are different models, there are different makes, there are different years and colors. At the same time, in the old cart market, there is a function of repairing, and repairing does add value. Records are kept, and the market has its own garage. When we talk about the garage, we're talking about the car mechanic workshop here. The old Car Mart also advertises about different cars into the local dailies. All the salesmen which are there on the car market are hired on the commission basis. They handle the customers, they negotiate with the customers, and then they forward the summaries as well. So, in this way, we have understood the background and the context of an old car market. Now, if we transform that old car market into the car mart, we see that the seller send the information to the old car process, which stores information into the data repository. That information is also sent to the central repository about the car, out of which three distinct functions are taking input. It is issue advertisement, decide prices, do repairs. Advertisement deals with the external users of newspaper. The prices are decided on the basis of the repair details because it is adding further cost to the existing price of the car. And also, repairs are involving another external user as garage. Then you see the process of sale is involving two persons, which is a salesman and a buyer. If you see the numerical number of 1, 2, 3, 4, and 5 is giving you a precedence of execution of different functions, that one and how, when and how these functions are to be executed. Now, if we look at the car mart, we see that the data stores and flows are clearly giving you a flow of information, that how different things are flowing inside a process and flowing outside of the process. Like, for example, when we look at the process 5 in the previous diagram, we clearly understand that buyer requirements and other details which are involved and associated with the buyer are clear from the fact. And once the information is given, it can list the requirements, it can list the cars which actually matches the requirements of the buyer. Now, if you if you look at this, you clearly understand from the ERD that one advertisement can have many cars. However, one car belongs to the one advertisement. A car can have many repairs. However, one repair instance belongs to the one single car. At the same time, a customer purchases the car. A car is a sold car when it has a relationship of sale with the customer. Now, with the ER diagram, we can move forward. Now, we look at an example 3 of the data flow diagram. When we look at the book supplier and we look at this diagram, which is a context level diagram, we see that the order processing system is a function with which customer and publisher are interacting with each other. Now, if you look at this data flow diagram, you clearly see that a customer is sending the order details to the order processing system, and the order processing system is generating a purchase order to the publisher. As a result, a publisher is sending a shipment back to the order processing system and receiving the processing and sending a shipping note to the customer, and customer as a response sending a payment to the order processing system that is then sent to the publisher. Now, with this, we clearly understand that how things are interacting with each other, including the external entities to the different processes. Now, when we look at the book supplier and we refine that context level ERD into the level 1, and we have exploded that process of order processing into further sub processes, we see that when a customer places an order about a book, a verification happens as the first and primary function, where the data of a book is verified and customer's credit rating is verified, because these are two of the things which are required to process the order: the availability of the product and the profile of the customer. Then the information is forwarded to the pending orders. Then the information is processed to the batch of orders information into the assembling order, where books are sent from the publisher. A purchase order is sent to the publisher, where the purchase orders are sent to the uh, they are moved to the further processing, and they are sent to for the verification of the shipment. Then from the pending orders, from the purchase orders, they get the final information about the assembly, and then a shipping note is sent to the customer. Now, this is the step 1 refinement. Now, if we look at the verify or assemble order, or the verify shipment, or the assemble order for the customer, we see that all of these things could be decomposed into the further sub processes, and as a result, it can give you such an information that gives you a logical view that how different sub processes are connected with each other in order to give you the final specific output of the function. This is one of the homework which you can take home to get an idea, to see the extensions of the data flow diagrams which we have studied in the lecture today. The book supplier, when the functionality could be extended further by if you add a function of handling the requests. So you can add a payment from the customers where you can create account receivable for the books sent, update receivable when the payment is received. You can have a credit rating which will need to be adjusted periodically. You can also give an extension to the functionality for the payments to the publishers, where you can have an accounts payable where invoices are received and then payments are made to the publishers. So these are the two of the functionalities which you can actually perform in order to extend your learning and understanding about the data flow diagrams. Now, if we try to summarize what we have studied by now, we clearly understand that process is modeled by the decomposition of the processes. And the data flow diagram clearly shows you the data flows inside the stores and the processes, but not the control flows. At the same time, it is also very clear that a proper naming of the data stores, processes, inflows, outflows is one of the most important part of your uh, process of making the data flow diagrams. So, whenever you create a data flow diagram, as we are following the bottom up approach, the top down approach, we have studied the examples first, and now we are going to decompose it and we're trying to understand this stuff. We see that, first of all, you are required to create list of activities which are expected to happen inside a system. And for example, we call it processes. And then at the same time, at this level, we're going to identify different stakeholders or the external users which are associated with the system. Then at context level DFD or a level 0 DFD, we identify external entities and processes. After the context level DFD, we create a level 0 DFD in which we identify manageable sub-processes. At a level 1N DFD or level 2 DFD we call it, or 1N level DFD, we identify the actual data flows and data stores which gets into the processes. And then we define the rules of a data flow diagram, which are already defined and we are going to discuss it in a while. All of your data flow diagrams are to be validated against the data flow diagram rules. So if I give you a revision, you see that the external entities are nouns inside a system. Now, if you look at the data flows, these are actually names of the data. For example, whenever we say that we give the order information into the order processing system, so it actually turns into the shipment. Processes could be system name or the subsystem name, and data stores are identified as nouns. So whenever somebody is telling you about a data flow diagram or a scenario or the statement of work or a statement of need, you can identify these processes and sub-processes and other things out of as noun and the verb phrases. So for example, a student can register himself on a student registration system. So student is a noun, can register is a verb, and student registration system is a noun itself. So with the noun, we have identified the stakeholders and external entities, and can register is the verb that an external entity can perform with the system. Now, we need to understand the process with a larger and a bigger example. In this example, we're going to understand about a lemonade. We're going to understand about the lemonade stand example. In the lemonade stand example, we are creating a data flow diagram where we are going to see that how the functions are performed at a lemonade store. Let's decompose this into a data flow diagram. So when we talk about a lemonade store, the operation is quite simple. At the data flow diagram, in the data flow diagram, we clearly see that at the laminate store diagram, we see that there are different activities. There are no use case diagrams, but the new ways to define a use case diagram in order to identify different functionalities. So at this point, I recommend that you use the use case diagram whenever you create a data flow diagram. If you have a use case diagram before the definition of before a data flow diagram, you would be having an added advantage to define the functionality. Um, Now, when we can construct the context level DFD, we identify the sources and sinks. Source is an entity from where the data is produced, and sink is the entity which actually consumes the data. At a construct at a level 0 DFD, we identify manageable subprocesses as I have explained earlier. At a level 1 N DFD, we identify the actual data flows and the data stores. You should know that what these three things are. When we think through different activities at a laminate store, we see that there's a list of activities. A customer comes to the laminate store, places an order, the product is served, the payment is collected, the product is produced, and then the product is stored inside the database. One more thing that I would like to uh, emphasize, and I want you to pay attention to it, is to understand that when we look at the data flow diagrams, we stay inside the boundaries and the scope of a system. There are many functionalities, like, for example, uh, maybe that person at a lemonade store is storing ice in the fridge, but that is not a part of a system. So we need to keep our focus on the point that how and when and where a person or external entity is interacting with the system. Now, at the same time, if it is a big laminate store, there are functionalities of ordering of raw materials, payments for the raw materials, and then if you have a labor at your, obviously somebody is there who is making all the ice cream or lemonades and selling it to the customers and performing all other functionalities. So you have to pay for the labor. Then, as a second step, we need to categorize the similar processes. If you look at the this functionality, you see that we have categorized different uh, different sub processes into the categories. Like we have uh, we have connected the customer order, serve product, and collect payment as one process, and then the produce product and store product as one, and then the raw materials and the pay for raw material as one, and pay for labor as one. Now let's move forward. So at a context level DFD, we see that the customers, employee, and vendor, because employee is going to have the labor and he is going to perform all the sales, and customer is the one who's going to pay for that and consume the product, and at the same time vendor is somebody who's going to give the raw materials. So now this is the context level DFD in which we identify sources and sinks in the data flow diagram. So when we see at the laminate system, the customer may places an order, the product is served to the customer, and customer also makes the payment. These are the three things which are given to the which are happening between the laminate system and the customer. Now when we look at the employee, we see that the uh, sales are conducted in such a way that laminate system is sending information to the employee is sending information to the production schedule, and then the laminate system is receiving and sending payment to the employee. And no, when we're talking about the laminate system, we first need to talk about the vendor, because a vendor receiving the purchase order in which there are details about the what are different types of raw material which are required. Then vendor sends the good, and then the laminate system pays for the raw materials which are received. At the same time, the sales forecasts are sent to the employee. Employee produces a production schedule. At the same time, an employee receives the paycheck, and from the employee as an external entity, you receives information about the time worked. Now, when we decompose that laminate system into four distinct systems and we give them a numerical number of 1, 2, 3, and 4, we clearly see that the inside inside a construct level DFT, we clearly see that first the first and foremost thing is the customer order, which is received by the sales process, and then the payments are also received by the sale process, and as a result sale process produces a sales forecast. When we look at a customer, we see that the production schedule is sent by the employee as a result of sales forecast, and then the product is served to the customer. The procurement module takes care of the raw material, as all the raw materials are sent to the production from the procurement. The vendor receives the information about the goods through purchase order. As a result, it sends the goods to the procurement, and procurement pays back to the vendor. Employee orders a decision to the procurement, a decision about the what kind of raw materials are required. An employee as a stakeholder or as external entity forwards the time worked information to the payroll and pays to the employee. So that's how normally it works when it comes to a construct level, a zero level construct, a level zero DFT data flow diagram. Now, if we further define that construct level 1N DFT, we identify the actual data flows and the data stores. And here we are just talking about the customer order and the collection of payment. So there are four functions, which is request forecast, sales forecast, payment, and customer order. From the customer's data store, we are recording the order, and order is then forwarded to the orders data repository. From there, the information of the served order is sent to the received payment, from where the payment is displayed and the payment is paid, and the same information is given to the payment. And then the produced sales forecast receives information from the payment data store and the order data store, and as a result produces a sales forecast, and the request for sales forecast comes from the user. Now this is the level 1 data flow diagram. This is the continuation of the level 1, where the served product is a sub process which receives a product order and saves the information to the order repository as quantity served, and order gives the information to the served product. Now when it comes to the produced product, we require the quantity used, so the same is to be deducted from the raw materials. That same information is sent to the store product, where the production data is sent, and the same information is stored to the inventory as quantity produced and the location stored. Now this is the further continuation of the level 1 DFD, where now the three now the over sub process 3 is further divided into the three bubbles, where the decision order, the received goods, and the payment approval is further divided into three sub-processes as produce purchase order, and the purchase order information is sent to the vendor. Now, if you look at it, you will have a clear idea that how a data flow diagram is decomposed into further sub-processes. Now we come to the fourth, where an employee is being paid against the labor. We clearly see at this level that the pay for labor is decomposed into and exploded, that bubble is exploded into three further bubbles, whereas time is recorded for the hours worked, payroll is calculated, and the employee is being paid. And the information is stored into the time cards, employee data, payroll data, and payments. I do understand that is at this level it might give you a confusion, but we can also try to define the data flow diagram in this way, where we can say that the processes are decomposed in such a way that the sale is decomposed into the record order or receive payment, and the second process, which is our production process, is further decomposed into the served product, produced product, and stored product. The procurement is further divided into the produce purchase order, receive items, pay vendor, and the payroll is further divided into the record time work, calculate payroll, and pay to the employee. Now, this is an example to understand few more things. Buses come to a garage for repairs. A mechanic and helper, as an external entities, perform the repair, record the reason for the repair, record the total cost of all the parts used on the shop repair order, and then information on labor, parts, and repair outcome is used for billing by the accounting department, parts monitoring by the inventory management system and computer system, and a performance is reviewed by the supervisor. Now, out of this scenario, we have identified that the external entities are bus, mechanic, helper, supervisor. Key processes are the system performing repairs, storing information related to repairs. And when we talk about the processes, the first process is the recording of bus IDs and the reason for repairs, determination of the parts which are required, calculate parts, their prices, and the total cost, and then the record of labor hours and the cost. When we talk about the data stores out of the bus repair system, we see that the personal files, repair files, master list, and the parts list are the data stores which are to be required in the system as processes or sub processes. And when we talk about the data flows, the repair orders are forwarded to, and the bus records comes to the process. Parts are recorded, employee time card is there for the labor payment, and then the invoices are generated against different buses. Now look at this system. This is a context level diagram. Now, if you look at the bus repair system, a bus comes with a mechanical problem to be repaired that is added to the system. A bus receives the information about the fixed mechanical problems. Now, in the bus repair process system, the repair summary is sent to the supervisor. The parts which are used from the inventory are forwarded to the inventory management system. So the new orders are to be placed from the inventory management system. The labor parts, cost, and details are sent to the accounting system for the production of invoices. A mechanic sends the labor hours and the information, and the same comes from the helper as the labor information to the bus repair system, so the salaries and the payrolls are calculated. So that's how the bus repair system is behaving as a centralized entity for the information processing. Now, if we look at another example of a burger order processing system, so the external entities would be a kitchen where the order will be produced from the restaurant, and then there will be customer. So what happens? Customer places an order, a receipt is printed inside a kitchen and a restaurant, food is ordered, and then the management report is produced at the end. Now, if we look at the lecture today, we have tried to define a clear understanding that how data flow diagram gives us a view of how the information is produced and consumed inside the system, how different processes are logically integrated with each other in order to give the final output of the system. That's where we conclude today's lecture. We will meet in the next lecture, and if you have any comments, questions, kindly do let me know and feel free. Thank you very much for your time. Have a good day. Bye.